This lesson in many textbooks is called curve sketching. For our purposes, we're going to be looking specifically at being able to find maximum and minimum points and be able to identify them as a max or a min without the use of a graphing calculator. So to begin this lesson, let's go back to a familiar problem. We had this problem earlier, and before we had any calculus at our disposal, and so with the use of whatever algebra skills that we had on the graphing calculator, we tried to resolve the solution of this problem. We came up with something along these lines where the maximum area occurred when x was this value, about 21.33 meters, which yielded a maximum area of around something like this square meters. So it involved a lot of guessing and checking and a lot of estimation, and it didn't seem quite efficient. And in fact, we learned that these were the kind of problems in the old times that mathematicians and scientists had to solve, and had to solve it to many decimal places for accuracy's purposes. And it was very tedious work. They needed to find a new mathematics to be able to find the answer, the solution a lot more easier. They needed a new calculus. And so now that we're studying calculus, you now have the tools to be able to try this problem again and be a little bit more efficient in your approach. So go ahead, take what you know about calculus, see if you can't find the result, the maximum area and the corresponding x value. Go ahead and pause now and try it. Okay, so hopefully you found something like this. You found the first derivative, you found the derivative of the area function with respect to x, maybe had something like this, and you realize that the derivative function tells you the value of the slope of the tangent line at any point on the curve. And so if we were to draw tangent lines all the way around this curve, at the very tippy top, the tangent line would be perfectly flat, which is a zero slope. And so hopefully you set your slope function equal to 0 and then solve for x. And so you should have been able to get some sort of value for x like this. And then you could substitute x back into the original equation to find the maximum area, and which is not 21, it's 910-ish. So now what we want to be able to do now that we have that background skill in place is, what if we don't have a graphing calculator and we don't have access to a graph like this? Certainly we can follow the procedures and we can find what when the function is equal to 0, our derivative function is equal to 0, but how do we know that that is a maximum or a minimum? After all, the slope of the tangent line at a maximum or a minimum are both going to be equal to 0. So how do we know if it's a max or a min? Especially if I have a complicated function like this, some sort of cubic, where there can be no max or min, there could be one max or a min, or two one max and one mix. I mean, there's a big variety of possible answers. So how do we do this? So let's go ahead and take a look at this graph and make an observation. Pause for a second and see what you notice about the tangent lines through these different points on the graph. Okay, hopefully you saw that the slope of the tangent line to the left of a minimum point is negative, and to the right of a minimum point is positive, and it's always going to be like that. If it's a sort of a U-shaped where there's a minimum point, we always have this relationship. The minimum, the derivative is going to be 0, to the left is going to be negative, to the right is going to be positive. Alright, and then if we take a look at a maximum point, we'll make the opposite observation. The left side of our point, the tangent lines are going to have a positive slope, and on the right side they're going to have a negative slope. So there's one other point that we're going to learn a little bit more about later on in the unit, but for right now, point of inflection is a point where, so like with a cubic, where it's curving in one direction and then it changes and starts curving back in the other direction. And so the point where it begins to switch back to the other direction is called the point of inflection. Okay, but for this lesson we'll focus on the max and min. So let's see a concrete example. Let's try to find the max and min points for this function. Well, the first thing we should do is find the derivative. And so we want to know where the derivative is equal to 0. And there are two x values where the derivative is equal to 0. And what we can do is substitute these x values into the original equation to find the corresponding y values. And so what I have is I have 2 points on this curve where the slope of the tangent line through both of these points is equal to 0. Now take what you know about sine diagrams and what the slope of the tangent line should be to the left and to the right side of these functions to figure out if this point is a max or a min, if this point is a max or a min. Take a moment, go ahead and pause. Okay, hopefully we found in the first point that we have a minimum. If you pick any random point to the left of our x value, so our x value is 0, so any numbers, so we might as well pick something that's easy, -1. We go ahead and substitute it into our derivative function. We get a negative value, and to the right side we get a positive value. If we look at what a negative slope and then 0 slope and a positive slope is, we can see it makes this U shape. So at the bottom of this U shape right here, that's going to be a minimum point. And now go ahead and try to find it for this point. Okay, hopefully you found that in this point you select a random point that's to the left of the x value. You see that it gives you a positive slope, and to the right side of that value it gives you a negative slope. And the positive slope looks like this, and then our 0 slope, and then our negative slope gives us this U shape. So up at the top here, that's going to be a maximum point. So that's how you combine sine diagrams, the derivative function, to determine if the points that you found are a maximum or a minimum.